Hello everyone, welcome to this session on getting started with serverless on AWS. Today, our goal is to get you started with serverless and give you all the tools that you would need to build your first web application with serverless. I am Suman Devnath, a principal developer advocate here at AWS. If you have any questions around the content being discussed, please feel free to ask them. We will be very happy to help you. Before we dive into serverless, let's first have a look at what our customers need to drive success. First, they want their teams to deliver products to their customers as fast as possible. Next, they want their applications and infrastructure to be reliable, highly available, and scalable. And lastly, they want all of this with the lowest cost of ownership. Keeping all of this in mind, let's go through a typical application development journey so that we can later appreciate the effectiveness and the value of serverless in a much better way. When we think about any application development in general, most of us start from here. This is the phase where we learn to develop, and we might have only one single machine to do all of our tasks, starting from running the firewall, servers, code, and database. And once our application tends to grow, we may try to move to a tiered architecture, where we run all of these in separate servers. In fact, we can even separate our client and the backend, as we can see here. But the problem with this is if one of these goes down, everything goes down. In other words, this architecture is not at all resilient. So to have resiliency, we need to add redundancy. And once we add redundancy, it would look something like this, where we will have multiple instances for our client servers, backend servers, and so on. So this architecture is surely more reliable than the previous one, where we had only one server in each of the tier for each task. But if we are building a production grade application, we may need to have more redundancy. That means more infrastructure. And more infrastructure means more management, more cost, and ultimately more servers. And when we think about servers, we have multiple things to consider, like what should be the right size of our server? How many servers should I budget for? How to manage the access control for all of these servers? And even things like what code change we need to put in our application so that it can handle any hardware failure. Like these, we need to address several other questions which are important and does matter if we want to make our application production ready. And this is what the biggest barrier is. With the traditional application development approach, most of the time is spent on operations and maintenance. So how we can mitigate this? How can we innovate and build faster without worrying about the infrastructure and the operations and focus only on our business problem? Say hello to serverless. So let's see how serverless can be plugged in to all of these architecture that we have just talked about. But first thing first, what is serverless? When we talk about serverless application, we talk about them in 4 key dimensions. First, that there is no infrastructure to provision or manage. You don't have to worry about servers, containers, operating systems, and patching. All of these are managed by us behind the scene. Second, it scales automatically, which means whenever your application demands more resources, it would automatically allocate resources without your intervention. Third, you pay for what you use, which means you pay only for the compute time that you consume. There is absolutely no charge when your code is not running. And lastly, it's highly available and secure. So now you can get away from all the hindrance of the operation and the maintenance task which we have just talked about and focus solely on your business problem and your application. When we think about serverless at AWS, the most important service to understand is AWS Lambda. AWS Lambda sits at the center of several trends in computing. But the most important thing to understand is that it's an event-driven computing rather than an empirical model where you walk through a program executing commands. Event-driven computing responds to events, and hence it is reactive in nature. The basic unit of compute with Lambda is a function. As you can see here, a Lambda function can be written in different languages or runtimes like Python, Node.js, Java, and so on. You can even provide your own custom runtime or create a Lambda function using a container image. As we have just discussed a while back, the basic model is event-driven. So when an event source happens, it triggers a Lambda function. This event source could be a change in the resource state or a request to an endpoint or a change in data state such as an object upload to an S3 bucket. Once the function has been invoked, it will interact with other downstream AWS services such as DynamoDB or S3. Not only that, it can even interact with any of the other resources that you have access from your AWS account via HTTP calls to other third-party providers. Let's take a look at the structure of a Lambda function before we jump into the demo. Here, we have taken an example of Python runtime, but these definitions hold the same for any other runtime. The entry point of a Lambda function is called a handler. The handler function is the function that will be executed when the Lambda function is invoked. The second thing that you would notice within this Lambda function is that it receives an event object. Event object contains all the data sent from the event source to your Lambda function during the Lambda function invocation. For example, for an API gateway request, the event object would contain all the information that was sent via HTTP. And finally, we have the context object. The context object provides us a number of methods that would allow you to interact with the runtime information which is specific to that Lambda function. It is one thing to talk about event-driven cycle, and it's another thing to see it. So let's go into AWS Management Console and see all of this in action. As you can see, I have already logged in to my AWS account. And you can find the Lambda function under the compute section here, or you can simply search for Lambda. On the Lambda dashboard, let's create a function. We will start with author from the scratch so that we can get a simple hello world example. Let's give a name to our function. In this case, we will say my function and select a runtime. As we mentioned before, we can select from a list of multiple runtimes with different versions that we are supporting. Or you can provide a custom runtime yourself. For this example, we are going to use Python 3.8. Choose Create Function in the bottom right, and AWS Lambda will provision all the resources for our Lambda function behind the scene. As we can see here, our function has been created. At this point, we are looking at the function overview section. Over here on the left, we can define our trigger that would invoke our Lambda function. These are the event sources that we mentioned earlier, like API gateway and application load balancer or any other AWS services. Let's go down and see what our function does. As we can see here, we have a Python file called lambda_function.py. And inside that, we got a function defined as lambda_handler with two parameters, event and context, which we have just discussed. This is the place where we can implement our actual code which solves our business problem. For this demo, we are going to manually invoke this lambda function by configuring a test event. And let's say that our lambda function would expect the event object to have a key called name. And all we want our lambda function to do is to simply return hello but the name in uppercase. So let's edit the code to do that. Now that we have saved our code, we can deploy it. Finally, we can configure a test event and test our lambda function. Let's do that. Now we can invoke the lambda function by simply clicking on this test button. As you can see here, we got the result as expected. The hello and the name but with the uppercase. Let's try to test with a different name and test it. As we can see here, we are getting a different response with respect to a different input to the test event. As we can see, it's very easy to get started with AWS Lambda and test it. But we can imagine when we start to build something real, we would need many different services interacting with each other. For example, we may have an API gateway as a trigger, a DynamoDB table at the backend, and so on. And in that case, we need to manage the IAM role and assign the right policy to the Lambda function so that it can access all the right resources. Not only that, if our code contains any external library, we need to manage all those dependencies as well. So next, we are going to discuss how we can build and deploy our serverless application more sophisticatedly. So as you are building more complex web applications with serverless, you surely do not want to do everything manually and would like to take advantage of the tooling and the automations. There are different options to select from, and our recommendation is to start with a framework. And which framework you choose is less important than actually choosing one. Apart from the tools and the frameworks which are available from many third-party providers, AWS offers many frameworks such as AWS Amplify, AWS CDK, and AWS SAM, which stands for Serverless Application Model. And today, we are going to look into SAM more specifically. You can use AWS SAM to define your serverless application. At its core, AWS SAM consists of two parts, SAM template and SAM CLI. SAM template provides infrastructure as code for your serverless application. It's very specific to serverless, but you can do much more than serverless within the same template. And SAM CLI is the tool which can be used to build the serverless application that are defined by the SAM template. So let's see how a SAM template looks like. As you can see here, we have only 21 lines of code. And in these few lines of code, we are building a lot. We are creating a Lambda function, an API gateway, an IAM role, and a DynamoDB table. What happens is these 21 lines of code then convert to infrastructure. And since it's infrastructure as code, we can version this code, make changes, and deploy the right version for the production environment. Now, let's jump into a demo and try to build a simple bookstore app where we will use an API gateway which will listen and respond to the HTTP requests, DynamoDB to store the data, and a Lambda function to run our code. To easily define and deploy all of this, we are going to use a SAM template. Now, let's see how easily we can build and deploy a serverless application using SAM CLI. For this demo, we are going to use AWS Cloud 9, which is a fully integrated development environment in the cloud, which lets you write, run, and debug your code within from your browser. But you can always do the same from your desktop or laptop or any other virtual machine like EC2 instances. All we need to make sure is that we have SAM CLI installed. And to check that, we can simply run sam-version. And once the installation is done, we can simply run sam init. This gives us the choice between an AWS Quick Start template or a custom template location that we can specify. Let's choose the Quick Start template. Let's select zip package type. And for our runtime, as we know that our code is going to be in Python 3.8 version, let's select the runtime as Python 3.8. Now we can give some project name. Next, SAM provides us some starting application template which we are going to use. And for this demo, we will go ahead with the first option called Hello World Example. As we can see here on our left hand side, SAM has already created a folder for us. Let's first go ahead and rename the folder called Hello World to My Bookstore app. And this is the folder which contains our application or Lambda function, as we can see here. But before we go ahead and write our application code in the app.py file, let's first go to the SAM template file and define all the resources that we would need to build our bookstore app. We are going to delete all the default code that we got from the Hello World template and write our own. Now, let's quickly go over this template file and try to understand what infrastructure it can build for us once it is deployed. One important thing to note is that AWS SAM is built on top of AWS CloudFormation, which is the service that we have to manage and deploy infrastructure on cloud by treating infrastructure as code. At the very top, we have this transform statement, which tells AWS CloudFormation that this is a SAM template and it is to be transformed to standard CloudFormation resources. Next, we have the global section. This section is unique to AWS SAM. It defines the properties that are common across all the serverless functions and APIs. As we can see here, we have mentioned the function runtime as Python 3.8, which means later on when we create a number of Lambda functions within this SAM template, we don't have to mention the runtime against each and every functions separately. Next is the resources section. This is the place we need to define all the resources that we would need for our application. So first, we are creating a DynamoDB table with a primary key of ISBN ID. And this is the table we will be using for keeping all the information about the books for our bookstore app. And here we are defining our Lambda function along with the API gateway as the trigger source. As we can see here, we have three different methods. One post method to add books, one get method to list the books, and one delete method to delete a specific book. And lastly, we are defining the policy for this Lambda function, which will allow this function to read and write items onto the DynamoDB table. Let's go ahead and save this file. And now we can go ahead to our Lambda function and write our application code. As we can see here, we are checking the HTTP method from the event object. And if it gets a get method, we are trying to read the details of the specific book or all the books from the DynamoDB table. And if the Lambda function receives a post method, we update the table with the new book information. And finally, we have a delete method which deletes a specific book. And since we are using some external libraries like Boto3 and SimpleJSON, as we can see here on the very top of this code, we need to update the requirement.txt file. So let's go ahead and do that. Now we are good to build the application. And for that, we need to go to the project folder and then use the command called sam build. This sam build command will now process our SAM template which we have just created, and it will build any dependencies that our application has and shall copy everything under a hidden folder called AWS-sam/build, as we can see here. So now that we are done with building our application, it's time to deploy it. And to do so, we need to use the command called sam deploy -- guided. Since we are deploying this for the very first time, we are going to use this option called -- guided. But next time onwards, we can simply run sam deploy. So what this extra option is doing for us is that it gives us an interactive setup to deploy our application. So let's go ahead and provide all the necessary information for our deployment, starting with giving a stack name. We are going to go ahead with the region, which is the default region, as US East 1. We can keep confirm changes before deployment or deploy as default. Similarly, we can go ahead with the default and allow SAM CLI to create IAM role needed for our deployment. So this is the advantage of using SAM. We don't have to manage all the roles and permissions of our own. SAM will automatically do it for us based on our application requirement. Now here we are getting a warning that our Lambda function add book function may not have authorization defined. This prompt is informing us that the application we are about to deploy may have an API gateway configured without authorization, which is true as we have not defined any authorization, which is okay for this demo. But in real world, we may like to add some access control mechanism via services like Amazon Cognito or Standard Auth. But for the purpose of this demo, let's go ahead and say yes. Next, it is asking if we would like to save all the argument to a configuration file or not. Let's go with the default, which is yes. And this enables us to simply use SAM deploy without using the -- guided option from next time onwards, as it will fetch all these informations which we have just provided from the configuration file. Now, this might take a couple of minutes to complete, as it is going to deploy all the resources on AWS on our behalf. So let's wait for some time and then we will resume once the deployment gets over. As we can see here, the deployment of our application is done and all the resources has been allocated. So let's go ahead and test our application. And to do so, let's go to our AWS console and go to Lambda dashboard. As we can see here, our My Bookstore app is ready. Let's get inside and grab the API endpoint URL for testing. For this, let's click on API Gateway on our left hand side. As we can see here, we have 3 triggers as we defined in our SAM template. One post method, one get method, and one delete method. Let's copy this endpoint and use Postman to test and invoke our Lambda function. Let's change this URL and send a get API call. As expected, we do not see anything and it returns an empty list. Since we don't have any books in our bookstore and our DynamoDB table is empty, this is very much expected. Now, let us test the post API call where we can send some information about new books. Here, as we can see, we need to parse the information of the new books in a JSON format. We can always use any other format of our choice, but let's go ahead and select the JSON format. As we can see here, we got the response as books data updated. That means we have our books data updated in the backend DynamoDB table. So now we can go back to our get API call and see if we can get these book information from there or not. As you can see here, we are now able to fetch all the information about all the books from our bookstore app. We can even specify a specific book ID and fetch the relevant information. Let's go ahead and do that. See, we are getting the book details of the book we are interested for. Lastly, let's delete this book by calling the delete method. And it seems like the book got deleted. And to verify that, let's go back to the get API call and send that API. As we can see here, that book is not there, and we have only the remaining 2 books. So our bookstore app is working as expected. It is surely not complete, and we have not implemented all the methods, error handling, and so on. But I hope you got an intuition of what serverless is and how easily you can build and deploy a serverless application using SAM CLI and SAM framework. So to summarize, to build a serverless application using SAM, all we have to do is to install SAM and then instantiate a project using SAM init, and then we can build and deploy our application using SAM build and SAM deploy command respectively. We have not covered every details of SAM in this demo, but you can always refer to our documentation to build something which solves your business problem. As we have just seen in our bookstore app, we used different services which are stitched together to build something meaningful. And this is a very common practice across all serverless applications, as they follow the design ideas of internet and the web. Before we wrap up, we need to remember that serverless is more than just compute. While many customers associate serverless with Lambda, we have many other serverless services at all layers of the stack, like Amazon Aurora Serverless, DynamoDB, Amazon SQS, API Gateway, and many more. To take your learning journey further, I would strongly recommend you to check this URL serverlessland.com to get regular updates, learning resources, and more things around serverless. Last but not the least, accelerate your cloud journey by checking out these featured courses to build your cloud skills on AWS, or visit the link below to explore more than 550 free digital training courses. Thank you again for attending. We really appreciate your feedback so that we can better understand the topics and the services you would like to know more about. So please do take some time to fill out this survey form and let us know what do you think. Thank you.